Hey everyone, welcome to the next video from Chapter 7. So in this video we're going from matrices that we talked about last video to what are called matrix functions, which are not too hard to see once you see the definition of them. And then seeing what this lets us do for our ODE systems that we talked about the very couple videos ago. So let's go ahead and jump right on into it. So by a matrix function, all we really mean is that our matrices, instead of having numbers in all the different spots, have functions in all the spots. So it's a matrix where the components depend on t. So I could have something like a of t is going to be cosine of t e to the t 1 sine of t. Every spot in the matrix is a function of t. That's all I mean by a matrix function. So we can do calculus on these guys. Calculus on matrix functions is done component-wise. What I mean is you kind of ignore the fact that it's a matrix and just do each function individually when you are taking derivatives, taking integrals, doing things like that. You just take it as each part individually and do it that way. So for instance, for that matrix, a prime of t is going to be minus sine of t, e to the t, 0, cosine of t. Because I'm just taking the derivative of each component individually. You can do integrals, you can do antiderivatives, you can do all this stuff with this. It works the same way, no matter what you do. Now, one thing to be aware of is things like the product rule. It works here, and it works in the way you'd want it to. However, you have to be careful about the order of matrices. Remember, we saw in the last video, for matrix multiplication, the order matters. So if I'm looking at the derivative of a product of matrix functions, this comes out to be dA dt times b plus a db dt. You have to make sure in each term the a comes first and the b comes second, because that's the order they were in the beginning. That's what they have to stay in the end, because order matters for multiplication. So now we can take this and we can go back to our system of first order linear ODEs that we had before. And we see that this first part looks like this middle part here looks like matrix multiplication again. So if I define a vector x by x1 through xn, if I define a matrix A by these p's, p11 of t, p1n of t, pn1 of t, pnn of t, and a matrix G, or a vector G, by g1 through gn, then this whole thing turns into x prime equals ax plus g. And that is one of the main reasons why we use these matrices to write these systems, because it gives a nice compact way of writing the equation, and then also gives us a way to analyze it. So if we start from this, it gives us a nice compact way to write it, and we can start trying to figure out how to solve it from here. So if we have a homogeneous equation, which means all the g's are 0, then this vector g is equal to the 0 vector, and we have x prime equals a times x. And the idea of the rest of the videos in this section trying to solve these equations in this chapter really is that properties of the matrix A should tell us things about the solution and should be able to let us solve these problems. And we'll work through sort of what these properties are and what they mean in the next couple of videos for the next section. So for most cases in this section, A is going to be a constant matrix, which means it'll be even easier to analyze properties of A to figure out things about the solution. All right, so there's the whole point of this video, and the point of this first day worth of videos is the idea that we can use matrices to write linear systems, and by talking about matrix functions, we can then extend all of that to linear systems of ODEs. We can write them in terms of matrices, and then we can analyze these matrices and these problems to figure out how to actually solve our situation. So that's the point for this video. I'm going to write up another problem for you guys to work on, which is basically going to involve you converting an ODE system into a matrix equation. So let me write that up for you right now. All right, so there is your problem for this video. Just take that, convert it into matrix form, and write out the x, the a, and the g that give you your matrix equations to set up this equation. All right, thanks a lot for watching, and I'll see you in the next video where we're going to do an example of getting an ODE from a modeling problem that might seem slightly familiar to you guys. Thanks for watching, and I'll see you in that one.